Hello and welcome to the first in the Crowbar install series. This video is intended to be the starting point where you actually can build a virtualized Crowbar environment. You could do the same steps for a physical gear. We have Docker steps. There's a whole bunch of ways to install Crowbar. We wanted to do one that was Windows friendly as your first and show you how to work it from the other ways. And then we're going to have separate videos that take you through different options of using Crowbar. In some cases, I'd recommend this would not be your first video. Actually watch how Crowbar operates in one of the later videos and then jump back and use this as your guide, how you're going to start. You can get into the Crowbar information a whole bunch of ways from our GitHub site. The README file here will take you into the docs. We build our documentation in the doc directory. There's a deployment guide. There's a development guide for building and development cases. We're doing a deployment guide. This actually walks you through all of the steps in all the videos. We're just at this first step where we're building our CentOS 6.5 machine. And I am not going to walk you through everything in this. We can assume that you're going to be able to build virtual machines for that. I will show you, this is what it would look like in VirtualBox running on Windows. That first machine, you're going to want to have a fair bit of RAM, at least 4 gigs. The directions are pretty clear for that. Multiple processors here. Actually, I'm going to up this to 2 processors. And you can make other choices as per what we're doing. The most important thing, of course, is going to be setting up the networks, making sure that you have internet access and not. And one of the things that we've done we have a SourceForge repository that has this base machine already set. You can see I went through it, sort of worked it out, and then stepped back and started over. I'm going to go ahead and boot that. And it's literally just a Cent 6.5, 6.6 image. I've done just some basic updates to make sure the machine was right, given it its IP addresses and internet access. So I've installed my keys on it. And then we're literally going to step in from that point. So all this work has been done. And then we have created a script that is very handy for doing some basic setup, downloading the OS, and bringing in your first image, the seed basically for booting machines. And so all those things need to be done to be successful with this install. Crowbar allows you to have different install disks, so you can choose which operating system you want to bring in. I'm going to connect over instead of working through the VM. I really prefer to work with a SSH session. It allows me to cut and paste a little bit more easily into these directions. The other thing that I wanted to show here, it also doesn't grab your mouse in that annoying way. So in addition to kicking off the script, the other thing I want to be able to do, I have a Win SCP session I'm cranking up, and one of the things that I would recommend doing is copying over, if you have them. So I have a whole bunch of ISOs for the different builds I want to do, Cent 7, 6.5. You need to have your TFTP boot ISOs directory populated with an ISO. If you do that in advance, if you have them, and you'll save downloading them into your system. And this step is not VM specific. It would be done anytime you're setting up a new system. So I'm going to take this step to run this script that we have created. This script does some configuration. It's going to download, sets my mirrors correctly so I can do a yum install. I'll show you what this script looks like. So basically it'll let me do a yum install. And click it. It'll let me do a yum install of Crowbar by adding the repos. And then it has some choices about hardware. If right now I'm not doing the hardware version of this install, if you add the hardware install, it's important to follow this step, and you actually have to go into this site before you can pull down these files. We cannot redistribute them. They are LSI files, and they need to be permissioned. This These changes are important if you want to do RAID or BIOS configuration. These LSI controllers is actually specifically for RAID. LSI downloads are required to run the hardware configuration pieces. Good news is if you don't need to do that or don't want to do that as part of your test, you can simply skip adding in that piece like we're doing in this demo. So if I'm doing virtual machines only, I simply skip doing the hardware RPMs or a separate RPM, and then that means that I can operate the system in virtual machines or any hardware platform that we're able to boot. I just don't get the added capabilities with hardware configuration. If you're interested in those things, please contact us on the list, or you can work with our company, Racken, directly if you want to support specific pieces of hardware that aren't in the open. We are always entertaining requests to support different hardware and add them. In some cases, we can do that in the open, or we can do it in a proprietary way if that's necessary. Our preference is usually open. So this is going to take just a couple more moments as we scroll through installing the packages, checking the dependencies. I will not have you watch as you watch me torture my internet provider. In some cases, if you're doing this over and over again, we strongly recommend setting up a squid proxy. That's actually part of our developer documentation because developers typically go into this pattern quite a bit. Of course, for developers, we recommend using a Docker container for the same effort because it's pre-populated with most of this information. I'll come back after we finish these downloads. So we've gone through the whole install process with this, or at least run that script. Right now it's down to loading that extra ISO. Since I already copied it in, I can happily break the script here and stop that, save myself a bit of time. And it's also a good place if you want to add other operating systems, then I would simply SCP them into that TFTP ISOs directory. Crowbar will discover there's an ISO there and actually builds the requisite Pixie Start install from those ISOs. That which also means that the first time you do this install will be pretty fast. Subsequent times through that process are going to be much faster because we cache those converted files. So from here, I've basically prepped my environment. I've installed the RPMs. I can do a validation. Actually see that it's been installed, tells me that it's updated. If I want to then update this, you need to erase the OpenCrowbar core. And there's some tips about this at the bottom of the instructions, and then reinstall. So the directory that we're going to build and install the base pieces for Crowbar are going to be OpenCrowbar core. I've changed over to that. And then from there, there's a script that we run called production.sh, which basically does the bootstrapping necessary to install Crowbar. So it has a chef solo routine that installs the Postgres and the Rails components and the prerequisites necessary. And then at the end of this script, it will call back into itself with a series of API calls that build the initial configuration of the data. For demos and testing, I highly recommend you do that. For a real system where you wanted to change some of the IP ranges and things like that, you can do these steps without that extra sequence, go into the website and make the changes. That's out of scope for these videos, but it's important to note that we don't actually hardwire the things that are in the production script. The production script is convenience because it matches 99% of the use cases, especially demo and proof of concept. So what I want to do is run the production script, and I want to give it the name of the network, the DNS entries, and the name of the first machine, and hit enter. And at that point, we're going to be going through and once again doing more downloads and installs as we actually make all of the pieces and parts work. This is really doing the Crowbar install itself, where we're doing the setup necessary for that. And I told you that we were using Chef, so you can see it's going through and doing the first Chef download. It'll take a little while, so I'm going to step back after we've reached the point where Crowbar is up. So we are back after a fair bit of time, right? We've downloaded a whole bunch of things. There's one or two steps in here where it looks like the system's frozen. It's just going to take some time to converge some of the Crowbar cookbooks and things like that. And then it's going to start the system, and then these calls right here are actually API calls where we are installing the first node back into Crowbar and doing bootstrapping. And I wanted to catch that so that I could show you where we stood with this. And what I've done here is I've gone to the IP address of my first node, 192.168.124.10.3000. I'm going to sign in as Crowbar, and then in this case, Crowbar itself is installing itself using, this is the system overview view. We'll spend some more time taking you through these in other videos. But it's worth coming in, and it's going through the process of doing the setup. So Crowbar, set up to this point, has installed Postgres and a Rails server and a backend thread engine. Didn't actually install any of the operational tooling that you need to run a data center like DNS or NTP. So we do that in this step. So now we're actually going SSHing back to ourselves and setting up the Chef server that we use to then coordinate all the other actions. Chef, of course, is not the only way to do this. There's other components that you can do. So at this point, we're basically handing off to the next phase of the demo. So this bootstrapping the admin server, and we'll spend some more time walking you through all these bits and pieces of what they do and how the UI works and what capabilities are in the system. One thing I would point out is we let the system run in this. Once you see this message where it says Crowbar Converge, you can stop it. It's not doing anything except waiting for the UI to finish, and then you can start playing with the Crowbar CLI if you'd like, which just points to the API, and you can start playing, investigating how the different pieces and parts go together. There's a fair bit about this in the doc, but it does take some getting used to for Crowbar. And watch the next video. We'll walk you through the UI and some of the underlying assumptions on how the system is working now that you have it up and running. Thank you very much. I'm looking forward to talking to you in the next video. So I wanted to add an appendix to this short video just to show you a little bit more of the networking that we set up in here for the VMs and let you know what it's going to look like when we boot them. So once again, host-only adapter. This is my primary network for administrative. This is my external network for getting access to the internet. And then this is basically a private network. This would be my OpenStack bridge or my internal communications band. Very typical for what we see in physical infrastructures. And then I have a series of slaves in the infrastructure here, and those don't need public internet access. They will get their access from the admin node. And for them, they have just two NICs. The first NIC is on the first adapter, that's their administrative interface, and the second one is on this public interface. And when you go to Crowbar and build it, this would be the 1G0 network. NIC 1, this would be the 1G1 network in our abstraction layer design. And then, very simply, I took that, I made sure that it could net boot. So let me show you how to do that. Here, I made sure network boot order was the top of the list. And then I went through, and it'll fall through to disk boot once you've gone through. Our DHCP server is able to tell the system how to do that on TFTP. And then I just cloned, I made sure this worked, and then I cloned it from its checkpoint back and created multiple slaves. So that once I have this system running and fully configured, then I can just boot these slaves, and they will pixie against the admin server and be off and running.